All right, chemistry, this is your video lecture for Chapter 5, Section 1. We're talking about the periodic law, specifically the history of the periodic table. So let's get started. Now, the periodic table is a way to organize or categorize the different elements that exist in the natural world, but it's not the first attempt to make a collection of them in an organized way. For example, triads is one of the first ways of grouping elements. They were in groups of 3 called triads. They were grouped together in these triads based on similar chemical properties, and the physical properties varied in an orderly way according to their atomic masses. So this is a very early, very foundational move to organizing the elements according to certain properties or certain traits. These ones use chemical properties and atomic mass. However, Dmitri Mendeleev was the first man who put together what we would now consider to be the periodic table. This is a picture of him. He's a Russian man. He did this in the 1870s, 1872. Now, Mendeleev realized that the chemical and physical properties of the elements repeated in an orderly way when he organized the elements according to their atomic masses. So what he did is he took the element with the smallest atomic mass, then the next smallest, and created an increasing atomic mass order, and that's how he arranged his elements. In 1869, Mendeleev published a table of the elements organized by this increasing atomic mass. Mendeleev was a Russian scientist and is often referred to as the father of the periodic table. This periodic table it's called periodic because it's based on the idea of periodicity. Periodicity is the tendency to recur at regular intervals. Okay, so when you have something like a periodical, a newspaper, it comes out at regular intervals. Okay, things like that. When you have a period in school, it's something that happens in regular intervals. So this is a quote from Mendeleev. The chemical properties of the elements are a periodic, right, regular interval, a periodic function of their atomic weights. And so when he was organizing these elements, and you can follow these on our modern periodic table, this is pretty darn accurate. It's pretty darn close to the way that we organize our periodic table. Hydrogen, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, on and on and on. Now, Mendeleev made some exceptions to place elements in rows with similar properties. Now, when we say exceptions, there were actually a few elements that had not yet been discovered. They were just completely unknown. And so what Mendeleev did is, instead of listing all of the known elements at the time in terms of increasing atomic weight, what he did is he still placed them in terms of increasing atomic weight, but he organized them in such a way that the rows and groups, the vertical columns, they would show similar properties, whether they're physical or chemical. And what that did is it created gaps in Mendeleev's periodic table. And what he did to explain these gaps, he said these are elements that have yet to be discovered. And in fact, he was correct. There was at least one element that when it was actually discovered by a scientist somewhere in Europe, can't remember off the top of my head, he named it, he described it, he talked about its atomic weight and some other properties. Mendeleev read his paper and then wrote him a letter saying that he was wrong. Mendeleev accused the man who discovered this element that his measurements were off because Mendeleev's periodic table predicted a different mass. And in fact, Dmitri was right. And Mendeleev was actually right in his prediction using his periodic table. And that's where we'll leave off today. We will finish up these notes next period. I will see you next period.